Welcome back, chemistry fans. I am going to finish now our unit 8 exam free response questions. Let me jump right into it, and we'll start off with question number 11. In question number 11, you are given a scenario where you've got some solid. You've got 116 grams of barium chloride, and that's this over here to the left side of my images here. And then you're adding it to 100 grams of water. Now, what happens though, is we end up with 103 milliliters. That's the important thing, because the formula for molarity is moles divided by liters. It's not grams. That will come later. We will use it, but not right now. So here we go. Let's jump into it. We've got 3 calculations based on those 3 pieces of information. We're going to calculate the molarity, mole fraction, and then mass percent. So molarity is moles over liters. I have 116 grams of barium chloride. So I have given to you what I wish for you to use as your weight. Barium is 137. Each of the chlorines are 35.45. So I add those together and I get 207.9. Don't do any rounding because I've given you the values exactly as I want you to use them. So 116 divided by 209, 207.9, and that gives you 0.5, 3 sig figs, 558 moles. Divide that by the number of liters. It is 0.103 liters because it was 103 milliliters. Don't use the 100 grams. That is the weight. I'm looking for liters and I gave it to you. So I plug these in and you end up with 5.42 as your molarity. Now the mole fraction. I've already got one of my values, 0.558. Mole fraction, by the way, is the symbol capital X. And down below, it'd be 0.558 plus the weight, the number of moles in 100 grams of water. So I will divide that by the weight of water, which is 18. So 100 divided by 18 is 5.56. So I will plug that in here, and we're going to end up with it. What it looks like is about 50%. So 0.558 divided by parentheses 0.558 plus 5.56. Oh, no, it's going to be much smaller. It'll be about 10%. So my answer is 0.0912. Multiply it. Oh, don't multiply it by 100 because it's a mole fraction. So that is my answer, 0.0912. Now, mass percent. Simplest of the calculations. So my percentage is the individual mass, which is 116, divided by 116 plus 100. So 116 divided by parentheses 116 plus 100, close the parentheses, and you get 0.537. Multiply that by 100 this time because it is a percentage, and you get 53.7%. Okay. So those are my 3 calculated values for question number 11. Question number 12 asks us to read some values off of a chart and figure out how much is going to precipitate out. So I've got KNO3, and I will highlight where KNO3, it's this line that cuts right through the middle of the graph. And it says that it wants you to say you've got 100 milliliters of water, which is what we expected. It's cooled from 50 to 35 degrees. So 50 hits it right here in the middle. It looks about 85, and it goes down to 35. That looks like it's about here, which is about 55. You're going to take the difference of 85 and 55, and you get about 30 grams should have precipitated out. So 35, and I believe those were the temperatures, 50 to 35. Yep. All right, that was stinking simple. All right, let's jump into question number 13. Now this one, we didn't have one exactly like this ever that we practiced, but if you read the question, it says that you have a first solution of 40 milliliters and a molarity of 1.8. It says then the second solution, which is this M2, has a molarity of 0.808, and it is 21.5 milliliters. Now, what we're looking for is M3. We don't know specifically what the new volume is, but we do because we just simply add together the 40 plus the 21.5, and you get 61.5 milliliters. So I got 1.8 times 40 plus 0.81808 times 21.5 equals. So this left side is equal to 89.372. M3 times 61.5. So now we just solve for M3 divided by 61.5. And what you get is M3 is equal to 1.45 molarity. Okay, well, this is everything that I wish to share with you on our test. So thank you very much for your time together with me. And I hope that you now understand your content a little bit better. Talk to you soon. Bye-bye.